Hello everyone, I am Dr. Raman. In this section we are going to discuss with Fourier transform problem with the Parseval identity. Find the Fourier transform of f of x equal to 1 minus modulus of x if modulus of x less than 1, f of x 0 if modulus of x greater than 1. Hence deduce that integration of 0 to infinity sin t by t whole power 4 dt equal to pi by 3. First of all, Fourier transform f of x equal to 1 divided by square root of 2 pi minus infinity to plus infinity f of x e power isx into dx. For this range, whatever given, modulus of x is nothing but modulus of x less than 1, it's nothing but modulus of x negative and positive. So minus 1 to plus 1, and modulus of x greater than 1, it's minus infinity to minus 1 and 1 to infinity. Therefore, should write this range split with minus infinity to minus 1 plus minus 1 to 1 plus 1 to infinity. This one interval to split with 3 interval because of f of x given different range. Now this minus infinity to minus 1, this value 0, and this value 1 minus of modulus x for f of x, this value 0. Therefore 1 divided by 2 pi square root, then 0 plus minus 1 to 1 f of x 1 minus modulus of x e power isx into dx plus 0. Now to substitute e power isx is nothing but minus 1 to 1 minus of modulus of x cos sx plus I sin sx, cos sx plus I sin sx. This is a e power isx expansion. Now this term to multiply with this term, what is the term? 1 by square root of 2 pi minus 1 to 1 minus of modulus x into cos sx, then plus 1 minus modulus of x sin sx I dx. Now this term modulus of x term is even function, then cos x even function, and this even function sin x odd function. So full range when minus 1 to 1, then we just apply with checking with odd function or even function. When even function into even function into odd function, therefore this value 0. Now 1 by square root of 2 pi 2 times of 0 to 1 minus x into cos sx dx plus 0, because odd function 0. Now when the positive side modulus of x, positive side plus x, negative side minus x, now 0 to 1 is positive side, therefore to write this modulus of x into x, 2 by square root of 2 pi 0 to 1 minus x cos sx into dx. Now integrate with respect to x. I mentioned already using the Bernoulli function, so this is a u and this is a v. Now integral uv dx equal to u v1, u dash v2, u double dash v3 and so on. Here u dash, u double dash is a differentiation. These terms are differentiation d by dx, and this is a v1, v2, v3s are integration. Therefore u is differentiation and integration u equal to 1 minus x, u dash, so differentiation, so 1 minus x differentiation 0 minus 1, u double dash 0, and then v cos sx v1 sin sx by the constant s, v2 minus cos sx by s square. Now what is the formula? uv1. So uv1, u dash v2, u double dash 0. Therefore Fourier transform f of x equal to 2 by 2 pi square root of uv1. So uv1 is 1 minus x sin sx by s minus 1 minus cos sx by s square, then other terms 0. So 0 to 1. Upper limit minus of lower limit. When should substitute upper limit? Where x term to substitute upper limit? Here x, here x, here x. So substitute upper limit 1. 2 by 2 pi. When upper limit substitution replace x1, the term 0, minus minus plus plus minus minus cos s by s square. This is the upper limit. Minus of lower limit, the sign 0 0, minus of minus plus plus of minus minus cos 0 by s square. Therefore 2 by 2 pi square root, this term minus minus plus, so minus cos s by s square plus 1 by sine square. Therefore, so if the problem only Fourier transform, this is the answer, 2 by 2 pi square root of 1 minus cos s by s square. So this is our Fourier transform. If the term, hence deduce that the term direct integration of same x term, then you just think the problem I think used for Fourier inverse transform. But when the power 4 it's happened, so I think to find the Parseval identity, when the power 4 use the Parseval identity. Therefore to find Parseval identity or use Parseval, using Parseval's identity. So what is the formula for finding Parseval identity? Minus infinity to plus infinity, Fourier transform f of x, the modulus square ds, then minus infinity to plus infinity f of x square into dx. Now to substitute the Fourier transform value here, minus infinity to plus infinity, 2 by 2 pi square root of 1 minus cos s by s square, the whole term square term, into ds, then minus infinity to plus infinity f of x. The f of x already we know that f of x only the range minus 1 to plus 1, then 1 minus of x, modulus of x square into dx, and then this term to take the square, minus infinity to plus infinity, 4 by 2 pi 1 minus cos s by s square whole square into ds, and then this is a term when square term minus 1 to 1, 1 minus of modulus of x square, when the square term, then we just apply with the even function. Now what is the even function? This is a even function, this is a even function. Therefore 2 times of 0 to infinity, to cancel this 2 times, 2 by pi 1 minus cos s by s square whole square ds equal to 2 times of 0 to 1, 1 minus x square into dx. When the positive sign, then the modulus of x is nothing but this is the modulus of x square dx. To cancel the left hand side 2, right hand side 2, therefore we have the value 2 by pi 0 to infinity 1 minus cos s by s square whole square ds equal to 0 to 1 is a positive side, therefore the modulus of x when is a positive side we consider x only, dx. And then integration of the right hand side. What is the integration? 1 minus cos whole square, we just expand this a minus b whole square form, or direct integration 1 minus x whole cube by 3, when the x coefficient minus, this is a minus 0 to 1. Therefore when substitute upper limit 0, minus of lower limit, when I substitute 0, then 1 by minus 3. This is a 1 by 3. The value is nothing but 2 by pi 0 to infinity 1 minus cos s by s square whole square into ds. Then just write this form, 0 to infinity 1 minus cos s by s square whole square ds. This 2 pi, when I change into right hand side, it will be coming with 0 to infinity 1 minus cos s by s square ds equal to pi by 6. But sometime this is a hence deduce that 0 to integration 0 to infinity 1 minus cos s by s square ds, then this is the answer. But the question is sin t by t whole power 4. Sin t by t whole power 4. Therefore, I want to change this term into t term. How to change? If 1 minus cos x equal to 2 sin square x by 2. I just change this term, 0 to infinity 1 minus, sorry, this is a 1 minus cos x to change in terms of 2 sin square s by 2 divided by s square whole power square ds equal to pi by 6. And then this term, to expand this form, sin square s by 2 power. So now put s by 2 equal to some t. From this differentiation with respect to ds by 2 dt. From this ds equal to 2 dt. Here s equal to 2t. The range should be when s0 then t0, when s infinity then t infinity. Change all the variable from s term to t term. Therefore 0 to infinity 2 sin square t by s is nothing but 2t whole square. This is a whole square. ds 2 dt pi by 6. And then to expand this, 4 0 to infinity 4 sin power 4t divided by, this is a 2t square, then whole square, this is a 2t square, 4t square, then again whole square. Therefore this is a 4 square 16 t power 4, then 2 dt pi by 6. Now cancel this 4 times, then to cancel this 2, therefore 0 to infinity sin power 4t by t dt. This 2, when I just take it right hand side, so 2 pi by 6, 2 pi by 6, this is a power 4. Therefore 0 to infinity sin t by t whole power 4 dt equal to, cancel this to pi by 3. So this is our answer when we are using Parseval's identity. Thank you.